Okay, it's 4 o'clock. Good day, good morning, good evening, very late into the evening, and thank you to all of you who are in unusual time zones and are up well beyond when you are normally up. You are attending the COIN Computing in the Network Research Group, and we welcome you on behalf of Jeffrey and Marie-José and myself, otherwise referred to as GEM. And you are participating in the IETF, so there are, for those of you who are longtime IETFers, know that there's a note well about the policies that affect various topics of discussion and conduct and patents. And we will be, of course, participating in audio and video, and so much of what happens here is of public record. All of these policies can be seen online should you choose to follow these links from our slides. And of course, the session the recording started several minutes before the session. And so please note that. Of course, this meeting is part of the sister group, the IRTF, the Internet Research Task Force, which really focuses on longer term research goals. And it is primarily not a standards development organization, but we are conducting research and trying to foster research and understand the gaps that may or may not lead to IETF discussion and uptake. But for those of you who haven't participated before, there's certainly a primer for participating in the IRTF for IETF participants that you can have a look at. You're here, so you've successfully maneuvered to being on this call, despite what that link says at the very top of this page. Please, if you are not speaking, please be muted. If you are presenting, feel free, if you're comfortable and have the bandwidth, to display video, although it's not required. And of course, we would love for folks to participate in the collaborative note-taking tool, which is actually not only specified here as a URL, but it's built into this tool, the MeetEcho tool. I personally am not participating in the Jabber, but again, everything has been integrated into this tool, so we can see your questions and we can see the chat window, and we will try to monitor those things as the session goes along. If you're not already on the mailing list, please join us there, and all the meeting materials are available through this URL. But again, wonderfully, with this IETF, you can easily get at all the meeting materials through MeetEcho by looking at the very top part of your screen, and there's a file folder icon where you can get at everything. If you have some limited view, just do a refresh and you should see the full set of slides there at this point in time. I'm going to hand over the floor to Jeffrey. I think. Jeffrey, are you there?
Yes.
Perfect. All yours.
Okay. So, sorry, I just wake up. So this is today's agenda. So as we announced in our minutes, our mainly will focus on the use cases, but we will start from two coin-related activities. One is the Picaro project. Hope Philip has joined us. And the second is the DAX2 seminar. The culture will introduce this. This is related to computer-first networking. And then we have three presentations about the use case. First one is from Dr. Charlson, based on their project between BT, Huawei, and Cambridge. And they will also introduce their insights or findings in use cases. And then the second is an introduction based on a draft Xavier Defoe programmability on mobile virtual networks. And then we have Chris to introduce his paper in the InfoComm this year. And after that, we'll have a short implementation to update the current draft, use case draft from Ike, then several topics after this meeting. So if we introduce something else here?
Nope, that's it. I mean, if you would like to say something about the documents, or Marie-José? Otherwise, I'll do the honors.
Okay, hello everyone. Yes, this is our document status. We have 2 research group documents, the use cases and the directions, which is expired, but I know from Dirk that it's going to be updated. Those are the 2 ones that are very high in terms of where they are in the stack, and they've been there for quite a long time. They're RG documents, and we intend probably in the next months to maybe push them to last call and push them into the up in the stack. There's a new draft, which is the case from the case study from Xavier, and then there's a bunch of other documents. Some of them are expired, some of them need care. So I would like everybody to remember that they need probably to be managed, and we are going to start going through them and contact the authors to make sure that they we know which ones are still ongoing and which ones will be more or less abandoned. You want to go to the next one? Oh, you're already in presentation. We had, I had a slide on some of the milestones, so maybe it's going to be presented later. We have, I would like them. Okay, we've basically addressed all our milestones. I would say, if I want to see the glass half full, I will say we're doing really well. If I want to see it half empty, we need to work on it. And actually, I'm going to mention that at the end. We intend to look at those milestones. We've done really good work, and I think there's a lot of good stuff that's going on. So, do we want to? We've been there for 2 years now, and I'd like us to probably, and we would like us, the GEMS, would like to see if we need new ones, which ones have been achieved, and which ones need to be updated. So again, without further introductions from us, we would like to go into the presentation. The first one, because of time, well, actually everybody is in the time that's presenting, I think, is in a bad time zone. So the first one is actually an update on the Piccolo project, which is looks at a lot of computing and networking, and the presentation will be done both by Philip and by Peter, and I will let them talk on their very interesting use cases. Philip,
Thanks,
you want to share your slides?
It's still here. No,
Oh, you want us to share them, right?
Yes, please. And I'm hoping.
Okay.
Well, then I'll go back to my.
Oh yeah, I remember. Okay, I'm sorry, Philip. I didn't remember that you had asked us to share it. So Peter, you are going to present though. So okay, so we'll start with Philip, and then we'll share the other 3. Okay, thank you.
So I'm not sharing my screen, right?
I can't see them yet.
Someone has to request the. So I'm a little unclear. Who is sharing the screen here? Are you wanting me to share the first set of Piccolo slides?
If that's all right, please, Eve. Thank you.
Sure. Let me go back. It is telling me that I have an error. And it's not letting me
So
share
if
the screen.
Phil clicks on the Ask to Share Slides button, then he should be able to select his slides.
Right. For some reason, it's no longer letting me share my screen. Okay, actually now
It says
here's
it's
the screen.
starting.
Oh, okay, good. Sorry, it wasn't letting me have access to the screen anymore. Is this me or you sharing? All right, which Piccolo slides shall I select? The use cases or the smart factories?
Use cases.
Okay. Sorry for the delay, folks.
There it is.
Whew,
Thank you very much. So I thought it would be easier for you to share it, but perhaps
Me too. Go ahead.
no, not
Sorry.
the case. So yeah, thank you very much. So we're going to talk about a couple of use cases and proof of concepts that we're working on in the Piccolo project. So Pierre's going to talk about smart factory, a smart factory use case shortly. But first of all, I'm going to talk about one that we're calling risk monitoring. So Jag and Dennis and Alex are the main people who've been doing the work, but I was the one who volunteered to try and stay awake. Okay, so yeah, on to the second slide. Thank you. So this is about automotive risk monitoring. So the idea of the use case is that it's a real-time assessment of situational risk based on the knowledge of a vehicle and the behaviour of the occupants and about what's happening around outside the vehicle and maybe about other things like the weather or the road conditions. So you know, so this is a kind of assessment of how maybe things like how dangerous it is at the moment. So you know, the combination of information from vehicle-based information, from other vehicles, from road conditions, from the driver behaviour, and so on. So that information might be displayed to the driver as, you know, as a warning, or it might be, you know, if it's a self-driving car in the future, it might be an alert to the human in it. Or you could imagine that it might be information to, say, a fleet manager, or in some kind of aggregated form, maybe to people like traffic planners. You know, and you can see that the different sorts of information will be wanted by those different parties. So next slide, please. Okay, so this is how you might try and do it today, or kind of the default way you might do it today. So there's video processing, which is separate from the vehicle data systems, both going into a cloud-based analytics engine. The visual processing would be done either on the camera, or if there's a, you know, a certain number of several cameras in the car, then you know, the VPE might be that visual processing might be combined across the cameras. So next slide, please. So this is our target architecture from what we're aiming at in the project. So I think the key message here is one about sort of flexibility. So flexibility in different sorts of ways. So, you know, one way shown there is that we want to explore doing some of the processing in the edge network, in the sort of fog network at the you know, in the operator cloud, near where the car is or the vehicle is, rather than doing it all within the vehicle. So that might enable you to have a simpler, cheaper edge node or cameras in the vehicle. So another way you might have flexibility is so that you can update and alter the algorithms, the machine learning algorithms, easier. So and rather than having often the software in these systems is tightly coupled to particular hardware in the vehicle, so to enable more kind of flexibility there. You might also be able to have different kinds of algorithms there depending on what sort of vehicle it is. So maybe a car wants to have one sort of algorithm, but in a bus or a tram, a public service vehicle, you have different algorithms that are trying to detect behaviour of passengers, or maybe you want information about how many people are wearing masks or not wearing masks, and that might be a current kind of example. You might want flexibility over which parts of the visual processing are done in the vehicle versus in this edge network versus in the center. So you can imagine, I don't know, the sort of simple low-level vision processing stuff like detecting edges of the image done in the car, but then more complicated things that involve motion detection or stateful operations are done in the network. Okay, I think, yeah, go on, next slide, please. So this is the design of what the proof of concept looks like. So we basically, the stage we're at is the components for different bits have been chosen, and it's now in bench testing or lab testing stage. So later this year, be moving into the vehicle. So the vehicle data side, which is the part that Bosch is leading. So there it's a Cuxa dongle, which is an open source software hardware project, which plugs into the onboard diagnostics port in the vehicle and extracts information from the CAN bus of the vehicle. That's then fed to this in the network. You can just about read the logo that says Geneva. So that's an alliance for connected vehicles platform, Linux based, for basically analyzing, doing the analytics. So then the part in the network, in the edge network, so Fluentic, who's a small company in the UK, are working there on secure containers, building on top of hardware security, so it's Intel SGX, and there's a secure containers framework called SCOAN that's on top of that does things like resource allocation and reporting from containers and attestation. And then Sensing Feeling, which is another small company in the UK who have various vision processing products today. So they're looking at changing that side of things and adapting which elements are done in the vehicle and which in the network. So next slide, please. Just the last one. So just to touch on some of the topics that are under development and research questions. So these are really under the general heading of control of the nodes in the network. So that's control of things like resource control, being able to flex that and adapt the algorithms there, or the frame rate, the cameras or whatever, according to resources. Things like about delivery of functions to the nodes and what sort of functions they might be, distribution of the functions. So things under the sort of general orchestration heading. Thinking about what control or knowledge the application might have over what the network's up to, and kind of flip side of that, what additional functions an edge network might want to offer. So maybe privacy filtering or locally scoped machine learning algorithms. Things under general security and privacy heading, which I touched on. And then bearing in mind this is a vehicle, so just the general context of mobility and how you handle the problems associated with that. So that's all I wanted to just quickly run through on that particular use case. Just one slide at the end about the project. Yeah, so that's it for me, and I can either answer some questions now or quickly, or Pia can talk and then have the questions at the end. But I see Kiretta, you're in there.
Hi, can you hear me?
Just about, a bit quiet. Or maybe I'll turn the volume up, that might help.
Okay, I'll try to speak a little louder. One of the questions I had, especially when you were talking about how you balance between the functions that are in the car and that are in the Piccolo node, is when it's in the car, you expect that your networking works because it's a wired network inside the car, and when it's in the network, your connectivity may either actually go down or experience fluctuation. So in designing the balance between what happens in the edge node and the Piccolo node, I think the safety of the car from the point of view of there's a function that I really needed to be secure, I really needed to occur, should be sort of maybe preferred to be done in the edge node. And also a fallback where if you detect that the connectivity is not as good as you might want it to be, you actually take on more in the edge node. So are those considerations also there?
Well, we certainly we've thought about them, and I think you're right. You have to be make sure that the things you're doing in the network are not safety critical, or if they are, you've got to work out how to fall back quick enough, and that's probably difficult. I'd say, well, I mean, we're exploring the kind of general. I mean, this is an example use case, and we're really using it as a way of exploring the issues about sort of distribution and orchestration, rather than sort of nailing the colours to the mast. That this is a use case that's that's really crucial. It's more a way of exploring what the issues are, and I think you're right. That is one of them associated with mobility. Is what happens if the network side of it goes down.
Yes, that sounds good. I think that especially in the case of the car where you want real-time actions in case the sensing system sees someone crossing the road unexpectedly or whatever. But
Yeah.
I'm sure that.
I mean, I think we're intending in the context of the demo, the proof of concept, that this is sort of the system stuff rather than taking over. I mean, I don't. Although I mentioned the self-driving car, I mean, that's a sort of an example of how it might be used in the future. Actually, in the demo that we proof of concept to do, it's human driving it. This is just
even in assisted driving, there are these cars that will detect that the car in front of you is closer than you'd like it to be. It's not driving, but it's giving you that beep 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 that hey, you need to slam the brakes on. That's not a function that you probably want in the Piccolo node or even deeper in the network. But anyway, I think
that's a fair comment, Chris. Yeah. Thanks.
Yeah. Okay, thanks.
Good comment. Good comment. Cheers.
Okay.
We'll be interested to hear how some of the issues of trust and security play out, and we'd welcome you coming back to tell us how you evolve that. I think we're into the second.
Thank you. Cheers.
The talk. Marie-José, I feel like I spoke over you. Were you wanting to say something else?
Oh, I was going to say we now have Peter. You'll have to be a little bit faster, so we maintain time.
Can you see my screen?
Okay. Can I share my screen, because otherwise you won't see the video.
You wanted yeah. Go ahead. Hang on.
Yeah.
Let me stop sharing mine. All yours.
My request is still somebody needs to allow me. Now it works.
There we go. Yeah.
Yeah, got it. Thank you. Okay, I'll rush you through the smart factories use case. First, I have to introduce about what kind of factories we are actually dealing with. So we will be actually getting access to a real factory, and we'll be controlling a real factory producing real things, namely these electrical motors, or actually electrical pumps for power brakes, like that are used in cars, in modern cars. And there's one of the few pictures I was able to actually get from the factory. So that's kind of like, you see the status where how they are kind of like coming in and out. That's from a test drive. But we'll see more of that. So first, let me introduce you what we want to achieve here. So normally factories are built kind of like on the drawing board, and then basically everything is programmed by hand. All the movement of all the pallets and all the processes and everything is kind of like handcrafted in PLC programs, and that is not very flexible and is also wasting a lot of effort. So the goal we want to achieve here is plug and produce. So you actually stick together your conveyor belt system, and then it self-learns its topology and routes pallets in a smart way, in an optimized material flow, basically, and that is built into the conveyor belt system and not using an external server. So that's how such an assembly line looks. And we'll just like skim over it. It goes in circles. We are actually distributing in the use case the pallets between these spooling machines. So these are the machines that actually spool electric motors. Each machine can spool 6 motors. And sometimes not all 6 work, so we have to be flexible in distributing the pallets and also different kinds of motors here. So that's actually a predecessor system where we have little nodes connected. I just want to show you like how this movement looks like. You have these pallets and you can go through corners, and they are taken by these conveyor belts. I cut this short because of the time constraints. Even it's like maybe. So let's head back to the conveyor belt system. So that's the floor plan of the factory. It was just the conveyor belt and everything else left away. And so again, we are focusing on this spooling machine things, and the blue dots that you see up here are the embedded nodes that we attach to the conveyor belt system, which are later sold together with the conveyor belt system, or that's the plan actually, to make it to a product of Bosch Rexroth, who makes these conveyor belt systems. And so if you take away the conveyor belt system, we have a kind of like mesh network architecture, so you can daisy chain these nodes, and some are connected to a switch, and so that's kind of like a typical network topology we would have in practice, and we don't want to depend on the topology. And the system that we implement is using message passing, kind of like an actor-based system, because we are using Erlang programming language and Erlang system, so we are running Erlang on all these little nodes. So we have processes, and we have these nodes, which are the actual compute nodes, and we have they're connected to a network, and the processes send messages. And that's basically all we care about. We can build everything with processes and messages. And the big question is, if you have a complicated system and a complicated topology, how do we automatically map these processes to nodes so everything works smoothly within necessary constraints? That's our core question. And here we have basically 2 modes of operation. We have a relatively static mapping, where we kind of like at startup know pretty much like where things would be, and some things would be on intermediate nodes. So only occasional recalculation here when preconditions change, like a node fails and we need to kind of like remap. And on the other hand, we have a very dynamic mapping, where we mainly want to use the compute power of all the hundreds of embedded nodes along the conveyor belt, and run complicated optimization algorithms like heuristic search, planning algorithms, and use all these compute nodes, so we don't need to run a big server for the optimization processes. And here processes can migrate and spawn regularly, and basically this is much more dynamic, and we want to do this with local knowledge. So if you look at these at our network from before, basically the static mapping is relatively local. So this is for the control loops that actually control the neighboring things, make sure that nothing collides on the lowest level. And the dynamic mapping is basically the whole network. We want to use all the nodes. So maybe just a short introduction, but without going into details. So I mentioned already that we implement all this in Erlang with built-in distribution functionality, and we run these directly on hardware, the Erlang VMs, so we can actually have this in small embedded systems. But I skim the details here. Our main research questions here are that can the orchestrator that maps all these computes to these nodes, computation of these nodes, be distributed in the same sense as the computation? So we don't want to have a controller node or a centralized node, but the orchestrator also needs to be sitting in all nodes, and they need to kind of like decide what happens together. So to solve the use cases, basically, we need to run a distributed online planning algorithm, so an algorithm that replans constantly, basically contains a digital twin and all kinds of heuristic search things. And is this even implementable on such an IoT-based system? Because that's kind of like a new thing that at least I haven't seen before. And how can we extend this into a generic solution for all kinds of similar network in-network computation? And with Ethernet TSN, which is, and also DetNet, if we have hard real-time networking capabilities and path reservation, this would be a possible extension that we actually can do hard real-time things in these networks. And
Peter, are you
would be the
ready
end of my
to show your
slides.
video?
Pardon?
Are you ready to show your video because you're getting overtime?
Yeah, I'm done. That was my last slide.
Oh, that was your last slide. Okay, great. We have time for maybe one question. Eve, you have a question?
I will ask myself to ask my question. I was wondering if you could give us a sense of what kinds of hard real-time constraints are part of the system in terms of the magnitude of maybe the control loops or other timing issues for the scenario you explained.
So the current system that only controls the conveyor belts like you have seen them in the video, there we have kind of like tens of milliseconds or 5 milliseconds, and soft real time would be sufficient because nothing bad happens if you're slow. It's just like the pallet doesn't move immediately. But if you want to kind of like do combined access, basically, like you want to, there is conveyor belt systems that can precisely control the position of the pallet, and you want to kind of like synchronize this with a robot arm. There you need to go to sub-millisecond hard real-time requirements, and that would be an extension of the use case.
Interesting. Thank you. Thanks for clarifying.
Okay, thank you both, Peter and Philip, for this update on Piccolo. The next one is Dirk. Dirk and Eve and John Crowcroft organized a fantastic seminar at Textual about a month ago, and Dirk is going to give us a teaser on the report of this this workshop.
Yes, thanks for giving me the opportunity. So I tried to use MeetEcho's new slide sharing feature, but it tells me that there are no slides available. I assume something went wrong with uploading them. So let me just share my my window here as usual. Just a moment. Here you go. Okay, yeah. Hi, everybody. Yeah, thanks again. So this is a quick teaser of our upcoming report for this seminar. It's of course impossible to summarize a 3-day seminar in 20 minutes, and so my co-organizers and I are still working on the report, to be honest. So this was a Darkstuhl seminar that took place earlier in June, fully virtual, unfortunately. But we organized it in a way that we almost ran it around the clock, which so put some particular burden on colleagues in the US and Asian time zones. So I think today is a bit payback for the Europeans. And so if you don't know Darkstuhl is a computer science convention center in a remote place in far west Germany, so in an old remodeled castle. And it's normally a great place for having in-depth research discussions in this secluded place. And so we of course wanted to have this on site, but you know, as you can imagine, that didn't work out. Was actually planned for last year, and so we just did it this year fully online. And so the objective were actually quite in line with our Coin research group topics here. So it's like discussing compute first networking, so as a moniker for a kind of new way to look at integrating or combining computing and networking. So so is there like a space for a new approach for doing that it goes beyond what we're already doing, so packet flow processing or just overlays. And so the idea was a bit learning from this distributed computing systems, trying to take advantage of recent trends in hardware and software technologies, and trying to shape a research agenda essentially. And I think it was a really interesting event. Thanks everybody who was there and put in all the time. So we have like 80 pages of notes that we are currently distilling. It's a lot, and many really interesting insights. So today I'm just giving you a quick overview and to make you excited for the actual report that is coming out soon. So maybe as a like motivation, so there are many successful examples of distributed computing systems that are used a lot, which actually the workhorses for many relevant applications today. So Apache Beam, all these data flow systems, and so on. They're all running as overlays. And so one way of looking at this is to say, could you actually do a better job by leveraging the network to optimize performance, but also make it easier to compose those systems? So these systems are very traditionally operated with like Kubernetes orchestrators and so on. So could you do this actually in a more distributed fashion, for example? And so if you contrast this simple data flow model, what you would actually like to have is an ability to compose systems flexibly, don't care so much about location identifiers, addresses, and so on. Maybe scale the system automatically, and maybe have a nice way to specify them, and then a nice automated way to operate them. If you contrast this with, say, for example, service function chaining, or like more networking-minded processing systems today. So these are more assuming that you are putting some function on a packet flow, and you are somehow able to do something useful with the data. And so these are really different worlds. And so we're kind of, I think, trying to overcome the left-hand side approach and yeah, find a better way to deal with to leverage networking capabilities for these relevant distributed computing ideas. Okay, yeah, just a quick pointer to the seminar and our virtual Darkshul Chapel photo. It's like not everybody is on there, but I think you will see some familiar faces, including 2 Coinrg coaches. Okay, the problem at a glance, I mean, it's difficult to capture this fully, but these are where the talks we had on the agenda. And if you have been to Darkshul, you know that so there are many additional things happening, and the value is often more also in the discussions that these talks evoke. But to give you an idea, we talked about use cases. So you had some of those in Phil's talk, some challenges, so in like general trends, but also challenges that have been observed by, for example, the Linux Foundation Edge project and the EVE sub-project there. And then a list of yeah, really cool research ideas, also some quite specific insights in, say, what is possible with current technology. So Per also introduced these ideas. And so we also in the end discussed a bit about what could actually be nice, say, more substantial research ideas, so PhD topics, for example. And so I just, it's a very eclectic collection here. I just picked some, say, highlights that I think should give you some idea of what has been discussed. So in general, why is this relevant? Well, we all know in Coinrg that applications are becoming more multi-party and distributed. With like things like DevOps, you would also like to constantly update parts of the system. So it's a kind of somehow loosely coupled, but should still be operational system. And if you look at like the hardware trends and like the more like the hard facts, basically, so computing and communication on different cost performance trajectories. So can you consider or can you leverage this for building systems that yeah, kind of make the most out of these these 2 domains? And so I picked just one use case topic here because we heard about the others before, and that is health in general. So for example, health sensing. So making use of all the sensors that we have, fitness sensors, pacemakers, and so on, and try to share the, say, analytics results of this data in like in a federated system. So not upload everything to the cloud and do it there, but do it in a more distributed way with like federated principal component analysis, for example, or base inference systems. And in addition, well, now in the pandemic, we are doing lots of contact tracing. And there are different systems on the market. Some of them are more centralized, others more decentralized. So in Germany, we have a fairly decentralized systems. We are largely happy with it, but it could be actually better because due to this decentralized nature, well, you cannot use the data to its full potential. So it'd be nicer if you could use the data to, say, have a bit more specific insights, so like prevalence in some areas, tracing particular virus variants, and so on, but without giving up the privacy preservation. So that was one idea we discussed. Then, yeah, split learning, so splitting up analytics vertically in the network is another interesting idea that could also yeah, enable privacy preserving analytics, for example. And that also seems to be quite interesting and lots of potential for like compute first networking ideas. Then for the facts, yeah, if you look at how like servers and switches develop and how they differ and so on, I mean, we know that you can do a lot in servers, and servers are getting better and say more efficient in access to the network, better hardware support, and so on. Switches, on the other hand, are also getting smarter and more programmable. But even with like programmable data plane switches today, what you can actually do with them is still quite limited. So it's not a Turing complete programming platform. And so these are still different systems. And specifically, we looked a bit into like P4 programming, and so it's many exciting opportunities, but also many constraints and difficulties. And so one thing I think concluded was that yeah, you can use this for some things, but not as a general in-network computing platform. So the question is more like, what role could these programmable data plane systems play in a larger system that also leverages, say, more like what we call server-based computing? And yeah, some research questions that we discussed. So what we need to kind of enable this new approach. So Per also alluded to some of these things just before. Yeah, placing compute functions in an intelligent way, optimizing the use of network resources and computing in a joint fashion. So enable, for example, compute graph layout optimization to see what's going on in the network, and so reason about, say, more static metrics, but also more dynamic, like load, congestion, information, and so on. And then optimizing the system also in different ways, move functions to data, and in the automotive discussion that Phil started, there was also the question, what are these areas and that you want to maybe consider? So of course you have to consider that there are control loops that are really critical that have to run in the car, for example, so time sensitive and safety critical things, for example. And yeah, so some questions. So some smart NICs are also enabling us to do things more efficiently, right, like FPGAs. And so what I mentioned before, we have to figure out how to use like P4 and switches for general computing, at least to support it in a meaningful way. And then, so the question is, how would these like platforms really look like in the future? And so how heterogeneous would the overall system also be? And so we thought it might be quite heterogeneous. So because yeah, the switch platforms are really different from like server or container platforms. And different topic. If you look at how to manage and orchestrate these things, so traditional systems, so like, you know, NFV but also like Kubernetes-based things, they are typically starting from a like the old, say, box model and then moving towards software. And so the way that we orchestrate systems is still a bit influenced by this old notion of that there's a bunch of servers in the end. And maybe it doesn't have to be like that. Maybe with a like more clean state approach, you could also arrive at say more lightweight design, where maybe orchestration doesn't have to play such a heavy role in the whole system. So maybe you can actually have a more like distributed, more self-organized way in these systems. And one tool for that that we also looked into was in-network telemetry, and so basically, adding more information to the actual communication that is used for distributed computing, for example. So something like feedback, congestion, or load information, these kind of things, which would enable the nodes themselves maybe to make some smarter decisions in the end. Then there were also some interesting contributions on, say, rethinking communication and computation abstractions more fundamentally. So, for example, starting from the idea that you would always communicate in a broadcast way, so in a like secure scuttlebutt system, for example, could you conceive distributed computing as like distributed memory side effects, so that you kind of broadcast or you broadcast the changes in the system and then implement them on local nodes, so in kind of this direction. And coming to the end, so there was a lot more, of course, but I just want to keep to the time here. And so our provisional summary here is that there are trends in hardware development, so that are actually important to understand. So like multi-core systems are also kind of limited because of thermal heat and power issues. There is an evolution of specialized hardware support, both on the switching and the, say, server side. There are platforms like Programmable Data Plane that are kind of useful for some things, but not as a general purpose platform. Then there are interesting trends in distributed application design. So in general, distributed machine learning with the different variants. And applications are becoming increasingly distributed and multi-party. And there are some examples of successful overlay systems that we think could actually benefit from, say, a new distributed system programming approach. So Ray is an interesting machine learning platform. All these data flow systems, they are interesting in a sense because their problem is a bit more constrained, but it fits quite well, of course, also to a networking, say, networking-minded approach. Let's say it like that. And so we think that there are interesting opportunities. So in developing these abstractions and platforms that do not treat the network as a black box, but are able to do this joint optimization, and that are also able to leverage these different types of hardware platforms more optimally. And then if you do that, there are interesting optimization potentials. So joint optimization, less centralized designs, and then finally really rethink the role of management and orchestration in that system. Yeah, thanks for giving me the time. Please look forward to the report that should come out in the next weeks.
And I think when you issue it, we're going to make sure to post it to the list so people will know where to get it. For sake of time, we should go directly into the next presentation. The other Dirk, who will present on actually something that's really related to what happened in Dagstuhl, which is a project that is being a collaboration on compute-first networking, and I will let Dirk talk about it.
Yes, good morning. We'll spare you the video. 2 o'clock in the morning here. Certainly don't want to see my face right now. Compute-first networking, as Moshe mentioned, project has been set up between Huawei, BT, and Cambridge University. CFN project team includes, John Grokoff, Richard Mortier, Phil, and Peter Willis on the BT side, Andy Reid, and a whole bunch of PhD students at Cambridge University. I'm only acting here as the one talking about some of the insights we got out of this. What is CFN? Mentioned collaboration. We look at the intersection of use cases, node and network technology for compute-first networking or in networking computing, if you will. We investigate use cases. That's what we started with. The project started with some delay. Jeffrey, who our co-chair, who was crucial in setting up the project, handed it over to me last year, and that led to some delays together with COVID. So we started effectively at the beginning of the year, end of last year, roughly. So we are currently in the use case stage. That led to requirements for node and network technologies, which we gathered so far. Next steps will be to develop key networking and node technologies, and also to provide a demonstration of key benefits for a selected use case. So this presentation today is about the use case part and fitting the agenda generally of today's meeting. We applied a taxonomy for the use cases that we looked at, and first, obviously looking at a brief description of the use case. What are the services that are used here and provided in that use case? What are the drivers? What drives the need for the solutions for, in the particular use case? And we also had aspects which I will not show today: expected economic value, references to market reports, time to demand. So when do we require, when do we require a solution that will rely upon some of the novel features we identified in short, mid, and long, and a lot of them mainly in the mid and long term, as you can imagine. Stakeholders in terms of driving adoption, for instance, user organizations, service providers, operators, but also sometimes, and you probably will notice that in the first use case, maybe even also regulatory bodies that could be a key stakeholder in these use cases. So the first one we looked at is distributed data storage as a meta use case, if you will, because it's being utilized in some of the other use cases as well. So there's a need for a vendor and a service provider, independent data ecosystem marketplaces that are open to all at a reasonable cost and with low entry barriers for storing data. The services here are distributed consensus systems, or DLTs, to some extent that provide discovery functionality to match constraints such as hardware capabilities, utilize security mechanisms, hash algorithms being used, or the proof of work pattern that's being utilized, and so allowing me to find and discover the right miners that match those constraints and perform the transactions, which includes the multi-point sending of constraint-based requests to a selected group of miners, and ultimately the actual computation over a pattern, a proof of work, proof of stake, or some of the other mechanisms that are being utilized. What are drivers for this? Well, why is there the need that was outlined before? Data sovereignty and locality we've found through several sources. The EU in particular here in Europe is quite, or the EC as the executive body, is quite heavily pushing for data sovereignty of EU companies, EU vendors, and EU nations, combined with a growing opposition to centralized and foreign-owned data platforms. COVID has brought some of these issues to light last year in places like here in Germany, for instance. Growing value in data gathering and sharing. Data is an important asset, right? And hence data storage, and maybe in a distributed manner, becomes crucial. As I mentioned, also regulations such as GDPR, which pushes things like locality quite heavily, and also purpose-oriented storage is one of the key issues. As a data, that's a meta use case that we identified that spans across some of the following ones, as you can see, and some of the organizations that are working in the various areas are also sometimes spanning into those additional use cases. So they're not only focusing on data storage per se. So one of the other use cases we looked into is transportation V2X. So it overlaps with what Phil presented before for Piccolo. So that's vehicle to everything, really, V2X as a communication between a vehicle and any entity that may affect or may be affected by the vehicle, with device to device, device to cloud, and device to network modes of communication that can occur. Some of the services here are general AV communication, computational calls, sensor gathering and fusion, and some of the ones we specifically listed, which again also partially overlap with what Phil presented for the Piccolo project before, is positioning through distributed AI, localized object recognition for level 5 driving, localized dynamic high precision maps, predictive accident avoidance, predictive vehicle flow management, and the virtual black box, that would be box, not block, there. Are some of the example services that use a mixture of the AI communication computational cores I mentioned before. The key in all of these services to provide a reaction capacity to the virtualized services with a fast rerouting, so that we have high dynamics that may happen between some of the distributed service endpoints. You would use the needed capacity through filtering and pre-processing that's happening. You have data privacy and access control aspects in these services, which links to the distributed data storage use case, as I mentioned, on where to actually access the data and how to localize data. Always connected to the best service, and then best service here in the air quotes that are not shown here. Computer-aware traffic steering is a key aspect to ensure that the service that's the traffic is being routed to is, for instance, not overloaded or has shortest delay possible, depending on what service we are talking about. These are some of the key aspects in the services that we observed. Drivers generally are the level 5 driving requirements in the various worldwide regions. There are some differences, but in overall they're rather similar, and you find these services across all of those requirements, if you will. The last area we identified are digital twins. Here, as a quote from the Digital Twin Consortium, digital twin is a virtual representation of real-world entities and processes synchronized at a specific frequency and fidelity. So it consists of data, computational, representational models, and service interfaces. The services are very similar to the BTX we saw before. So again, generally AV communication computational calls and sensor data and fusion, but maybe with somewhat different goals, if you will, in the digital twin. So you have a lot of data retrieval, fusion, and storage aspects, and some of the solutions that I looked at in the various consortia are, again, as mentioned before, very heavily based on DLT solutions. Distributed AI computations for the models using, for instance, gRPC or RDMA-based invocation models. Computation patterns that you can observe may be generally multi-point, so one-to-one, one-to-many, many-to-many, with short-lived groups, which is very, very key. So they're not the usual longer-lived multicast relations. And that means to often need to optimize communication as well as the computation pipeline. The example for that is a live feed AV with a feature extraction and centralized unit, where the computation pipeline optimization may be more important than the communication optimization in that case. Drivers here are, again, several vertical industries such as manufacturing, automotive, supply chain, aerospace, defense. That's a very, very long list. There's an emergence of a number of industry initiatives I mentioned before. The Digital Twin Consortium was already quoted before. The IETF and Gaia-X are some of the other initiatives that work in various aspects. Gaia-X very much on aspects like data center interconnect aspects, the data storage, obviously, aspects as well there. So what are the requirements that we derive from these use cases? We've been focused particularly on the notion of computational processes. That's why these processes were mainly listed as computational calls, sensor calls, etc., being identified in the network system. So the notion of the computational process is the important part, not necessarily the computing network endpoint, which leads to various requirements that we outlined for identification that links to processes and the obfuscation of the purpose of the communication. The announcement of computation within and across domains. Also the need for delegated announcement and maybe even pre-announcements are described or are being derived from some of the use cases. The interconnection, a lot of these communication we see happening in what's captured in obviously 8799 as limited domains that are very stakeholder specific. Some of the stakeholders that I mentioned before in the vertical industries that are involved in the initiatives. But there is obviously a requirement to interconnect across limited domains where, in particular, the public internet comes into play. Also requirements that allow us to bind to available computational instances under dynamic constraints. Both Phil and Per talked about this before in their talks around being able to build dynamic relationship between the service instances as they are being deployed in the network. The constraints here may change and obviously vary per use case, but may also change over time. And hence these bindings may exhibit dynamic behavior as well. Collective communication patterns that are potentially even request specific can be found in a number of the use cases on distributed reasoning that I mentioned before. And an IPv6 support for making this work in an IPv6 environment through suitable potential extensions is another requirement we derived. Some of the requirements I wanted to note that here to make a linkage there are already captured in the existing Coin use case draft, as I mentioned before. That brings me then finally to the next steps. So for Coin, the next steps from our side is to consider the integration of use case and requirements in the existing use case draft. That's quite easy, given that I'm one of the co-authors. Wanted to bring this to discussion with the other co-authors for the next iteration to maybe bring some of the insights from the CFN work in there to see what's missing, as that some of the use cases are already in there in part, so it should be quite easy. For the CFN project, I mentioned in the objectives before is to pick a use case of choice. We haven't done that yet. So which one would be worked with in terms of a system architecture and a demonstrator. The demonstrators planned for next year. The system architecture work will happen this year. So that's something maybe also for another update to the group once we have more to share. Good, thank you. I hope I made up a bit of time.
Yeah, thank you very much. Well, I think it's a great idea that you want to include this into the use case document. And by the way, we're going through a lot of use cases in this meeting, and I think the goal of the minutes will be also to organize them in such a way that we have a better view of all of this and move a lot of the discussion to the list. Since there's no question, and I'd like to have more time for, oh, Eve has a question.
Yeah,
Okay, quick question, Eve.
Quick. I was curious to know about some of the consortia that you're listing. I can hear an echo. And so I wondered if you think that some of those places are organizations that we should hear from due to their interesting perspectives that are either adjacencies or overlap with some of the goals here. What are your thoughts there? And does the CFM project also interact with those consortium as well?
Well, the CFN project only through the partners, indirectly. So not as a project itself, because the project itself is a research project. We have some involvement in some of the initiatives. Gaia X is something where Huawei is very active in. One of the ones that I didn't mention, I don't know exactly why I left them out, because it might be quite interesting, is the IIC, the Industrial Internet Consortium, where the Industrial Ledger, I have to use the right word, task group, I think it is currently preparing a white paper that may be quite interesting. That's something that we initiated in that particular group, where we presented some work on the impact of DLTs on networks. And that has to do with the way DLTs work. We specifically looked at Ethereum as one of the examples there. And does it really work the way we expect it to work? What are some of the issues that are caused by the involved network technologies? Are there any ways to improve on that? We picked the IIC because it had that dedicated ledger group, but I think that's maybe also something, and the ledgers themselves are quite important in the IIC because of the aspect of, again, data storage. And these are maybe some of the discussions that may be quite interesting for this group as well. So I think in the data space, there may be something that could overlap
there. In fact, there was a question on the chat window from Chris about were you targeting Filecoin in one of your slides when you were speaking about the ledger technology?
Well, we started with Ethereum just because of it's quite easy for us to study. I've also looked. I actually had a call with Jonas a couple of months or weeks ago. Filecoin is another one because of some of the changes that we find is quite interesting as an evolution from Ethereum to Filecoin. So it's not specifically targeted at Filecoin. And all these platforms are all part of this distributed data storage, and also the question of how the network can help with any of that. So some of the problems we outlined in the operation of Ethereum really have to do with some aspects of network issues that we all know, like non-routability to miners, even though miners have announced themselves, and the associated problems that has, right, on the operations of the DLT. Now, Filecoin has specific mechanisms to tackle some of those at the overlay level, which is the reason why we've also looked at it as a potential.
Thank you. Thank you so much for your very interesting talk, as always.
Thank you.
And
thanks for having
me. I'd be curious to understand pointers to some of those consortia. If you want to post it to the group as a follow-up on the email, that would be wonderful. Thanks.
Yeah, absolutely. Absolutely. I will.
And repost. That would be fine as well.
Okay, so sorry. So we were talking over you. Okay, so thank you very much, Dirk. The next is, at first it was supposed to be the presentation of a draft, but when we started talking to Xavier, we figured out it was also a new use case, and it is for mobile virtual networks. So Xavier, please go ahead.
Thank you. So I'd like to present a use case on programmability in mobile virtual networks. Right. So this draft, describes a use case for Coin, where a P4 programming interface is provided to tenants of virtual networks. So P4 is therefore used as an external interface by the operator of the underlying network. So virtual network support for P4 has been discussed in Coinrg already, right? Especially the multi-tenancy aspect of it in the MTPSA paper in reference here. So however, use case can help looking more broadly at the impact of data plane programming on virtual networks. And here, 5G LAN is used as a base for the use case because it's well documented and it's a good starting point. But actually, this use case uses three well-known technologies, P4 for data plane programming, 5G as underlying network, and 5G LAN as virtualization technology. And the goal is to initially study the problem, without too many moving parts, because all those technologies are known. But this is a starting point, and we can look at expanding the programming aspect and look at how P4 can be used for more things than today. So we can also look at other underlying networks and virtualization technologies as well. And finally, this is for study only. There is no related work in 3GPP. Right. So we can now take a look at the rationale for P4 programming, right, for mobile VNs. First, data plane programming can be used by tenants to control increasingly complex virtual mobile networks. So we need to cope with the evolution of future mobile networks towards more and more customized environments. So we can expect very diverse and granular network services, including computing services. And I would say besides handling complexity, another point is to enable interchangeable or at least portable programs for VNs over various underlying networks. So then we will be able to use the same tools to mix and match portions of physical data center and mobile network segments. So let's look at the high-level description of the use case. So a 5G LAN connects group member devices. So here we have the mobile devices UE1 to UE4. And device 1 and device 2 are attached to UE4, acting as a bridge or switch. And a 5G LAN tenant is also part of the use case. So it can be an industrial, enterprise, or home network operator. The mobile network appears as a logical switch to the tenant, and the tenant deploys P4 programs on the switch, and it can also operate a controller communicating with the switch using the P4 running API, runtime API, sorry. So now we can look at some aspects of the underlying network. Right, so 2 points mostly. I mean, first, the P4 program needs to be deployed on physical nodes, and possible locations include mostly these user plane functions. So you have anchor user plane functions represented here, which are at the edge of the 5G domain, or you can have intermediate UPFs as well, and you can even deploy some P4 programs or fragments or programs on mobile nodes. And a second point I'd like to highlight is that you have like 3 different types of 5G LAN data path or modes of operation. Right? You have like the blue path between UE1 and UE2 is basically using the switch component on the UPF1. The green path between UE1 and 3 is passing through a tunnel between 2 user plane functions. And finally, you have another mode of operation where the data path leaves the 5G domains, goes through an external data network, and re-enters the 5G domain later on. So that leads us to the requirements and research challenges. Well, first, P4 programs will need to be splitted or distributed because data paths are distributed with no central node in the general case. Right? So this can be an input to the Coinrg draft on P4 distribution, which is in reference here. In particular, in this use case, distribution is not for scaling purposes or performance. It is needed to process all packets. Right? And a second point is multi-tenancy support, or a second requirement, I would say. Multiple 5G LANs can share the same infrastructure, and the MTPSA paper mentioned earlier and other related studies provide useful solutions in this space. And the fact that programs may be distributed and multi-tenant at the same time could also add some additional challenge. A third point is about mobile network awareness. Like a P4 program could interact with the mobile network system and, for example, it could learn parameters associated with the flow. It could also influence the processing of a flow by the 5G system. So, for example, based on some processing, you could select a particular slice, or for example. And fourth point or fourth requirement is mobility support. Since you are in a mobile system, P4 programs would, in this case, need to migrate in order to follow data flows when mobile devices move from one attachment point to the next. And finally, there are security risks, including overusing network resources, injecting traffic, and accessing traffic from other users. Right. So here I like just to summarize. Data plane programming, in this use case, is a way for tenants to control virtual networks over various underlying networks. And as a starting point, we can use P4 for data plane programming, a mobile network as underlying network, and 5G LAN as virtualization technology. And since these technologies are known, that helps us narrowing down the focus initially and make a first analysis. But there is room for developing this use case further, and so that leads to the two following questions. So do you think that this use case is appropriate for Coinrg? And a second question is, if are there people interested in developing some aspects? So we have, related, for example, to new data plane programming approaches, or maybe improving P4, as that has been mentioned in the Dagstuhl seminar summary. And also, and after that, also we could look at other underlying networks, data centers especially. And of course, we could study the impact on those changes on the requirements and challenges. So please let me know if that's the case. And in any case, thank you for your attention.
Thank you very much, Xavier. I can summarize a little bit what was discussed with the use case authors, that maybe this could be one of the use cases. Then that would, we would need to talk about, does it still need its own draft? There's also a question from Dave Oren. Do you see the question in the chat, Xavier?
I would have to stop sharing if you don't mind.
Yep. So the question, I will read it, is he says doesn't want an answer now, but maybe you can give ideas of the answer about P4 virtual 5G network. He says that we've had virtual router technology on conventional routers for 20 years, but nobody could figure out how to deal with the required isolation properties or the ability to properly soft or hard partition the resources. And actually the question is P4 making this easier or harder? So maybe you can just give a few pointers, and then we can move that to maybe to the list or to personal communications, because I would like to move next.
No, thank you for the question, and I think that's a good question. And when you speak about bringing a P4 program on a data plane program inside the mobile network, you don't necessarily, it's not easy to get positive feedback, because it's a very controlled environment, and that's seen as dangerous. But so I think that you would need some form of interface between, the integration between the mobile network and the P4 switch would need to be controlled and under the control of the operator, in order to avoid the security issues. I didn't see any big blocking issue, but I may not have thought of everything. So, thank you.
Thank you very much. Yeah, maybe that's something we could take to the list.
And our next talk is Chris, who will be speaking to us, in fact, giving us a preview of his paper that's been accepted to InfoComm 2021. And Chris, you're welcome to start sharing your screen while I give a little bit of background about you. Chris is a PhD student who's finishing up this year. So for all of you out there who are looking for talented technologists, Chris will be on the market shortly. His defense is likely sometime in the December timeframe. And he's looking for a position in research, in R&D, mainly in industry, but potentially academic positions as well that are closely linked with industry. And we'll hear about his work around Send, but he's also looking in the future to be focused on storage within edge-based network systems, and specifically towards service and or performance efficiencies and optimization. And I just want to underscore that this is exactly the kind of talk that we really enjoy hosting. So for all of you other academic advisors or technologists who know about really interesting research groups, we love hearing from people who are researchers in all stages of their development, and we encourage more of it. So without further ado, Chris, I hope I haven't embarrassed you too much, but we're looking.
Oh, that was amazing. Thank you very much. That was really nice, actually. Thank you. So yeah, I developed Send basically as kind of an adaptation on storage towards a better transmission and servicing basically of data towards the clouds and edge basically. So yeah, within the presentation, I'll go through the introduction of edge data repositories, which were basically developed before this paper was done, just as a means of storage at the edge and to basically make an introduction to storage rather than caching. Then we'll go into how Send was designed. Basically, we'll introduce the labels, which are mainly the main metric for the whole system. We'll go into like basically some data categories and the strategies that developed from the labels and that enable the system to use these labels to get well the best performance basically that it could, at least in my opinion at that point. Then we'll go into like some developments basically into how these packets are generated. The evaluation itself we'll be going through it just briefly so you understand basically its impact, and then we'll go into some future work and we can discuss afterwards. So actually, like this, the edge data repositories concept was partially inspired by Eve's work in reverse CDN, basically, as a concept, as a blue sky concept at that point. And yeah, like I started working from this paper and Yanis's mobile data repositories at the edge. And then I developed a store process send system, which effectively incorporates the idea that you, whenever the system gets some requests from the edge, it will always store the data that it needs, and whatever future requests come, it will be able to, it may be able to satisfy some of the requests with the stored data that is already in the system, thus being able to actually provide very good servicing in some cases, and some it may not, but as it showed up until this point, it can improve computing systems by quite a lot. So as we, as everyone here knows, any computing system is generally made of at least like a processor, main memory, and I/O, right? Thus, we can also provide in the in networks, right, the processing power, activity, like active memory, which it can be per application or can be managed differently depending on the application, and I/O through the network. So this important part, in my opinion at least, of computing was left out until recently, which is storage. And yeah, this needed to be addressed at that point. Of course, making the differentiation between cache and storage. That is, sorry. Oh, I accidentally skipped a few slides there. Okay. So yeah, I developed store process send for that reason, which is like it was developed for the reverse flow, as I said, of data and for service adaptability. Then for this to be implemented, I used two definitions of timing for data to be stored, which is the freshness period and shelf life. These were basically the freshness period would represent a deadline for the execution of a time-sensitive processing function, and the shelf life refers to the maximum storage period or the maximum window for the data to be processed by a function at the edge. So once the data shelf life expires, the data should be archived to the cloud. Yeah. Thus, as the last point mentions here, basically this all needs some management and some way of actually managing all the data within. So I developed storage network data. At this point, basically we had to have a median storage environment, which is basically drives the data from the bottom towards the top while having services at the center of the model. So it could interact very easily with data providers, which are also like application providers, basically managing at least some of the data, if not most of the data generated at the edge, while also being able to provide a secure and useful storage environment for any of the other entities within the system. This represents, the schematic basically represents an internal algorithm for for how storage would work. Basically before this, it was pretty dumb, the system. Then we implemented some more intelligence in the fact that it started having some feedback loops, and it started looking at and this was already implemented, which is basically function instantiation and a feedback loop for that. It was towards the cloud, and it was implemented without storage beforehand. So these parts actually influence how the data is stored within the repos, so that the whole chain is actually changed and the processing can be done better within the system. So yeah, the labels themselves offer the ability to track performance, the popularity of data, and the data placement statistics, which is so this is on top of the freshness period and shelf life, and it provides a means for other strategies to be implemented on top of it, so that the system can actually use them to its advantage and to the served user's advantage, of course. It makes the system aware of the data context, and it can improve performance exactly because of that. So there's more potential in that, and we are well aware of that, and we're working towards that basically at the moment. They also enable accurate data placement and storage decisions, because they can be used for the above reasons, basically to both be placed and to duplicate basically the data depending on where it's needed. So yeah, they are the most, labels themselves are the most essential part of the system. Thus, from here we basically decided that we had to have a structure within our how should I say, data population, right? So all the data are individually hashed. They have different identifiers, but at the same time, they all come with labels, which can basically classify the data and make it easier for different entities within the medium to both identify and use the data more effectively. So then we decided that, okay, so like these types of data have to be of different, how should I say, should have different scopes. So storage related, function related, and then offload bound data, basically, like cloud bound data. So both of these can become data to be offloaded to the cloud at any point because of the fact that they have a freshness period and a shelf life to deal with. But at the same time, they can be relevant for a certain amount of time, or even a prolonged amount of time at the edge. And yeah, because of the above, we've developed 4 different placement strategies, and then we evaluated them. So yeah, like we then had a prototype evaluation that was using a Google file system for timings and like basically local timing assessment. That was specifically for getting good and accurate measurements with regards to task completion. Basically, then at the scaled up network simulation study level. So yeah, we got really good results. Basically, data insertion time was of between 0.06 milliseconds and 0.9 milliseconds, which is, yeah, like arguably good for some, maybe not for all applications, but at least for some, and lookup times that are also comparable to that. And yeah, as use cases, we used some V2X applications as well, actually. So, and for that, we got 92% user requests satisfied, basically. The data sets were realistic. There were like 3 data sets, 1 synthetic and 2 cloud-based, like data center-based data sets. And we used, as I was saying earlier, we used the baseline for comparison, a non-storage, but a function feedback loop based application that was, oh, sorry, I accidentally went out.
Are you close to? Oh yeah, you're the future one.
This is my last one. Yeah.
Thank you.
I was just gonna go back, but yeah. So yeah, we're now looking into developing further into more intelligent systems, basically more architectural and intelligent network storage systems, mostly at the edge, though. That's it. Thank you very much.
I'm in the line, but I'll get out of the line since I'm hosting this. Eve has something.
Oh, go ahead, Marisha. Say, please.
No, go ahead. I will ask my question after. Dave, okay. Your question is part of the discussion that's ongoing, right? It's not related to this presentation? Okay, Eve, go ahead.
I had a couple questions. I was just scrolling back in the chat window. My first question was, who or what creates the data labels so that they can be processed better as parts of functions or services in the network?
Okay, so basically it's the applications. Like that is the main creator. That is, so basically when a data provider sends sends an IoT device, let's say, right, at like at the edge, to a user, a user. The user can actually basically apply their own labels sometimes, or like they're basically configurable. That's the main idea.
Yeah.
Right.
Okay. Fair enough. And I guess that goes hand in hand with my other question, which was you had a slide about sort of the different categories of data, you know, function based or cloud
Right.
oriented,
Yeah. Okay.
or, you know, and so I was curious about also, and I suspect your answer is likely around, you know, the application tells you so, but where, how do applications tell, or functions for that matter, tell in what direction your data is bound, like to where, what is the actual eventual migration?
Okay, so
destination?
that's different. I guess I didn't get it through basically. Then the main idea here is that, you know, like your application is generating data, and it may need certain data to be queried at certain points in time. It's not about where the data is bound. It's about basically it can be stored within any kind of environment, right? That's the whole idea. You want it stored within the network, whether it's in a data center or locally. Well, it's none of the user's business, is it? It's just that the network itself provides the data whenever it's needed.
But then you were also saying, you know, okay, if data gets generated as a function of a function, as the output of some kind of computation,
Yeah.
and it doesn't fit in your repository, how, is there, you know, I presume with this federation of repositories that something advises or recommends where you might migrate your data to that might have space, or how to take action, or, you know, and all of those
Yes,
things.
we're actually tackling that.
Yeah. Okay. So is that an ongoing issue?
Yeah. So it's like part of the work. I mean, it's not that I didn't implement it before. It's just that so like beforehand, I just sent it to other repositories basically whenever not enough storage would be available. But in like at the start, even with quite high like shelf lives, they would still live for quite a long time and still have quite a bit of storage empty. So it was good. Like, and I had actually pretty low storage associated with each repository, and that was, yeah, like it was satisfying to see.
Great. Well, if you can get through the presentation of a talk at this late hour in your time zone, anything will be easier, I imagine. So good luck with the Infocom presentation. It'll be at a more reasonable time zone, hopefully, for you.
Thank you.
Risha, did you have a question too?
No, I will skip. It was about assumptions, but it's probably in the paper. So I actually read the paper once, but yeah, actually, maybe I can ask a very quick question. Actually, for once, we're ahead of schedule. What are your assumptions about? That was my question, actually, because you went directly into details of the implementation. But what is the assumptions that you have on the underlying capabilities of the network and of the storage?
Right. So I actually used like so I used the simulations, and I used the Icarus. I don't know if you're aware of it. And like I don't know. I had the different. I had different like request generation amounts basically per second. That was depending on the data sets mainly. They were like up from I don't know 100 or like not 1,000 up to like almost 10,000 requests per second. 16 data repositories distributed differently. The requests were distributed depending on the.
I think it's not that type of assumptions. I think it's more about, in what type of operational system would this be applicable? But we can take it offline. And for once that we're ahead of time, I want to keep ahead of time. Yes, if maybe you could answer that question, what type of operational system would use this, which is something I'm interested in. Anyway.
Yeah, okay, sure.
Yeah, let's move it offline. So that, again, I'm so happy we're.
The email list, right?
Yeah, let's move this to the email list. If you could answer to the email list, by the way, that would be great. So yeah, we're doing well in terms of time. I'm so so happy about it. We're usually so much late. Okay, Ike is going to talk to us about we had decided that we would not really talk about drafts, but since this was a use case directed meeting, we decided to have maybe short presentation, and the only people who asked for a presentation was the use case draft, which makes sense since it's related to the theme. So Ike, please, you have 5 minutes. So I said these were going to be lightning talks.
Yeah, and I'll also try to be very brief. So this is actually the first update that we give now that the draft is actually no longer the industrial use cases, but the general use cases for in-network computing. So basically what we did, as suggested in the last update that we did for the industrial use cases, was to include all the other aspects, basically from the other draft that Dirk was also working on. And then we also have two additional contributions, one by Marie-José and one contribution by UC London. And yeah, so we are still getting bigger in this draft and having quite a lot of new use cases. But right now we're just at the point where we only have the descriptions for the different use cases, and only roughly following the scheme that you can see here in the middle. So also opportunities and research questions, for example. And what we really would like to do eventually is to start analyzing the use cases so that we can then actually start to derive basically a research agenda maybe, or try to group the different use cases that we have in a bit more sensible way than what we've done until now. And for that, we are obviously always looking for new use cases. And as we've seen today, there are quite a few of them out there. And actually with Xavier, we are already discussing the possible addition to the use cases draft. And if you're also feeling that your use case would fit nicely into the draft, then feel free to approach us so that we can then work together on contributing or on putting that together in the draft. And yeah, the concrete next steps that we have are trying to somehow condense what we've heard today into the draft, and then also potentially start with a rough analysis maybe, or at least try to get the draft into a more consistent shape. So right now one can still see who has contributed what, and it's not like a consistent structure in all places, and that's something that we would like to work on next. Yeah, and that's already it.
Thank you so much. I'm the author, so I will probably refrain from more comments because we could do that. Anybody has questions? Again, I will not be, now I will, it's, as the chair or as the chairs, we will probably have a look at this. This is a research group document. Maybe we can talk to the authors, including myself, into, again, putting it in shape and start moving it up the stack. Because again, there's two very important drafts right now. There's the one that essentially defines the framework, which is Jorg's and Dirk, and this one who actually shows how the framework can be implemented. And then in our other milestone from there, there's other things that can actually flow from there in terms of, improved protocols, improved storage networks like we heard in this presentation, other specific implementation. Yeah. So Eve, can you put our last slides?
Yes, I can. Let me share.
So the last slides are basically some announcements and some, I would say, logistics and house organization. Probably a few of us, a few of you have seen in the past few months, I had posted the request for a workshop at Connext, and it was accepted, actually, thanks to the hard work of a number of people who are on this call and a few who are already asleep. So Fernando Ramos from Portugal, Edgar Ramos from Finland, where I don't know if he's still online, but where it's close to 3 in the morning, or more than that, actually. They're 7 hours away. And Dirk Trossen and Rute, who is in Munich, and me, and we submitted it. I'm sorry to say that our true beautiful website is still not online, but we do have already a CRP site. The paper submission is September 20th, and the workshop will be on December 7th. And again, I would say this is an effort of the working group, so of the research group, sorry. And I was very proud of that, because this is one idea that we had for the research group, but also to spin off a few things. If you saw today, Noah Zilberman also posted another workshop. This one is much closer to what's going. It's a hackathon. This one is much closer to this time. It's actually at SIGCOMM, so it was posted today, but after we uploaded the slides. There's going to be more meetings, obviously. We're not done with this. This is just also, it's been 2 years, but I think after 2 years, we've basically scratched the surface of everything that can be done. There's, as you know, there's other groups that are also looking at, then Charlie Perkins, just as I'm talking, just posted that he has a meeting tomorrow. And in that meeting tomorrow, there is a presentation on computing in the network that we hope that we can maybe include in our next presentation, and maybe in October. We'll probably have, we'll be in Madrid virtually or hybridly for sure. And I think December is an awfully busy season for everybody, but another idea that we had always, kind of thought about was to co-locate our interims with related conferences. The ICN people have done it extremely successfully. We'll see, obviously, of course, Connext is going to be virtual, so it's not that people are already there and they can come to the meeting, but it's the theme of the week. So maybe if the theme of the week includes some things related to coin, that maybe we can, profit from that. And if we don't co-locate it, then we can maybe make it not too long after and profit from all the presentations that will be presented at the workshop. And also the workshop, we intend to do something either in CCR or maybe a special issue of some magazine, so that we could also continue to take advantage of all the presentations. So for once, we finished 5 minutes early, which is very rare for us. So thank you very much. I posted it already. Thank you very, very much for all the presenters who We're really good at maintaining schedule. Thank you very much for everybody who stayed up into the wee hours to support this. California people, for once you had it really good. Us, it's time for dinner, so it's probably not too bad. And we'll obviously, another thing that we would like to encourage us, the JEM is, I'm losing my English now, I live in Montreal, is to encourage more discussion on the list. We haven't very much used it that well, so I would like, that's why I said today some of the questions should go on the mailing list, and already some people have answered, which is great. And would Eve or Jeff having something to add?
Nope, not here. Not here. Thank you.
And so,
Yeah. Thank you for participating.
and thank you again to everyone participating, and to make this group, I think, a really exciting one. And actually, I can say that I'm humbled to be part of it. Thank you so much.
Thank you. Bye.
Eva, do we close this thing? We just leave?
I think you leave the room all the way on the right, and the buttons at the top.
Yeah, I know, but it will close the session.
Yes, it will.
Okay.
At
Bye.
the top of the hour, it will. Okay.
Oh my God, Edgar, you're still on. Yeah. Good. Well, actually, good morning for you. Bye.
Bye-bye.